Hello, welcome. I shall continue the discussion on static force analysis. Unfortunately, in this topic, my role is very little, and whatever I have the role that I have already explained, and it is your involvement, your work is more really here, and it requires a lot of practice and one more session in that direction. For static force analysis, I shall not go in detail what is static, etc., all that. I have made a statement here, okay. So in such problem, while solving such problem, static force analysis, I have written a statement there. Please go through that. Look for two force link. Okay, when you start your analysis after drawing all that configuration diagram, so identify the link. You spend couple of minutes, couple of seconds, and then go through all the links and identify the link which is a two force member. Okay, look for two force link, and draw free body diagram of the same, and find LOA. It is not a standard notation. Line of action. Find line of action of each force on that link, and then proceed. Okay, so then move to an adjacent link where you can proceed with your analysis, etc., and accordingly you carry on. Okay, then I also, what is the meaning of this? The meaning of this sentence, I have taken the two examples which I have already done. Okay, so a slider time mechanism, there is only one force P acting on link number 4, and link 3 happens to be a two force member. So you are expected to pick this and find the line of actions of F23 and F43. Once you know the line of action of F43, you know the line of action of F34, then consider the free body diagram of link number 4, then draw force polygon and find out the unknowns, and then come back here and then come back here and find out what is T2, which I have already demonstrated. Similarly, in this problem, so there is no P here, there is only Q. There is only Q, and similarly, link 3 is no more a two force member, but link 4 is a two force member. What are the forces? One is F34, the other one is F14. Only two forces. Then find out the line of actions. Then come to the free body diagram of 3. Then you have what is called as F43, then Q and F23. Make use of the conditions of equilibrium of a three force system. The three forces must meet at a common point. That is how you find out the line of action of F23. Then you draw the force polygon and find out the unknowns. Then take the free body diagram of 2. That is how you can find out P2. So for this is what I mean. For this, I have taken this example. Now let me come to this. Okay, a third problem. Here I have both forces P and also Q. P on link number 4, Q on link number 3, and I also have to find out what is called as T2. Now, link 2 is not a two force member, link 3 also is not a two force member, link 4 is also not a two force member. So this is for such situation I have written here. If we do not have such a situation, what do you mean by such situation? A link having only two forces. If I don't have that, then what to do? Go for principle of superposition. What is the meaning of principle of superposition? If you have a number of forces, I take only one force at a time and find its effect. And to get the effect of all the forces, then I individually do it and then add it to get what is the net effect. That is called as the principle of superposition. Okay, so and create a link having two forces. Say for example here. Okay, so none of the link is a two force member. Therefore, I go for what is called as principle of superposition. What I do? First, I assume Q equal to 0. If Q is 0, then it is a case of first one. Then I can easily find out what is T2 of the first problem. Then I assume P equal to 0. Then I shall have only Q. That is nothing but the second case. Solve this problem twice. And then find out each time what is the effect. To get the total effect, then add the two effects. This also has been demonstrated already. And this is what is the meaning of this. If we do not have such a situation, then go for principle of superposition and create having a link, having only two forces, and then proceed. This is what I mean by this. Okay, and this is not applicable only for slider crank mechanism. This is always for any problem of static force analysis. Okay, so now with this background, let me proceed with the problem which has been sent to you. The problem is with you, you have already written, I presume it. Okay, if you are not, then please copy it and then come back and then start watching. I also have, I hope you already have those the instruments with you. Okay, so the problem is very simple. It is a 4-bar mechanism now. I move on to 4-bar mechanism. So any kind of slider kind mechanism, the connecting rod may be in the form of a line, or it may be having any other shape, quadrilateral, triangle, whatever it may be. The method remains same. The only thing is you need to practice and gain confidence so that you can attack any problem without any difficulty. Remember, this is a highly reliable question. Highly reliable question from the examination point of view, and therefore you need to practice. So let me move on to a 4-bar mechanism. Let me read along with you. A 4-bar mechanism is shown in figure. This is the figure what has been shown here. ABCD is a 4-bar mechanism. This is AD frame. This AB may be input link number 2, and BC link number 3. Okay, coupler, and CD the output link. Okay, so this is the mechanism, and the link number 4 is subjected to a force P. Okay, and in explanation it has come there. A 4-bar mechanism has shown in the figure. Okay, fine. A force P which is equal to 100 Newton at 120 degrees. Please see here. So this is the force. This force P passes through point E. If I extend it and draw a horizontal line, this horizontal line can be drawn anywhere, it doesn't matter, and that force makes an angle of 120 degrees. That is the meaning. Okay, 120 degrees on link CD. This is link CD. Okay, fine. Full stop. The dimensions of various links are AB 40 mm, AB this is 40, then BC 60, this is 60, then CD 50, this is 50, and AD is 30, this frame is 30, and DE is 20, this is 20. All the dimensions are given, and determine the input torque, the torque required on input link, that is the meaning. The input torque on link AB for static equilibrium. So though I apply force, I don't want none of the link to move, and for that I have to apply a torque T2 on this link. And how much is that T2? The magnitude and also direction. Okay, as usual, the first step, what is that? Drawing what is called as configuration diagram. You need to draw the mechanism to scale. Okay, what is that? I shall start with the frame, I shall draw 30 mm. Okay, before that, probably you may assume scale 1 centimeter is equal to, okay, what are the dimensions here? 30, 40, 60, 50, probably I can go for 1:1. So 1 centimeter means 10 mm. I can assume the scale. Okay, it means it is same 1:1. Okay, 30 mm the frame that I draw it. What is this? This is the AD, the frame. Okay, then I need to draw input link which is 40 mm. Okay, so one data is missing here. At what angle I have to draw this 40 mm? Okay, that information is missing. So therefore, I need to assume here. So many times, remember this is a question problem from question paper. Okay, so you come across these kind of situations. Probably you already have come across, and here you know that this angle is a must. Without knowing this angle, you cannot proceed this, construct this diagram. Therefore, assume angle BAD. Some angle you have to assume it. Looking at this diagram, it makes something like this. It is more than 90 degrees, and I shall assume say 120 degrees. Please remember, I have assumed, and for this assumption, I am going to solve it. If you don't assume, you can't proceed because you won't be able to draw the diagram itself. Okay, then I assume angle BAD is 120 degrees, measure 120 degrees, and draw this. How much length line? This is 40 centimeters, more than this. So maybe something like this. And the diagram what I am drawing is not really to scale. Please remember here, it is only a demonstrative. Okay, an indicative diagram. Therefore, the exact diagram, when you draw it, you will come to know the shape. Okay, there may be slight change in the shape. And then BC is 60. With B, this is B. With B as center and 60 mm as radius, you draw an arc, something like this. And CD is 50. With the D as center and BC 50, then probably you can join this, and this point is what is C. Okay? Then you mark what is called as point E. DE is equal to 20. So you get point E. Okay? So at point E you have a force of 120 degrees. Please remember, check here. This 120 degrees, how is it? 120 degrees is not this angle or not this angle. 120 degree. The line of action of the force makes an angle of 120 degrees with the horizontal. But I need to indicate that. So this is my starting point. I want to draw this line. How should I draw it? I just draw another horizontal line. This line is parallel with this. If this is 120 degrees, what will be this? You know that this is 60 degrees. And therefore, at point E, I draw a horizontal line. Then measure 60 degrees. This is 60 degrees. And draw this line. Now put arrow. This force is what is P, which is equal to whatever that 100 Newton. Now you can draw this and show that this angle. How much is this? This is 120 degrees. Fine? Okay, so now all this diagram is over. Now let me make this mechanism. It appears like a quadrilateral now. It is not a 4-bar mechanism. So to make it, convert it into 4-bar mechanism, I need to draw 4 small circles at A, B, C, D. What do they indicate? They indicate turning pairs. Okay, now it has become a 4-bar mechanism. I shall have a frame, fix this and call this as link number 1, this is link 2, this is 3, this is link 4. Then I shall also indicate what is called as, this is the top P2, I need to find it out. And this force P, everything is known. Okay, fine. My diagram is ready. And before I proceed, okay, since I need to draw what are called as the free body diagrams to scale, therefore I just draw a horizontal line at B, and find this angle. How much is this angle? Let me call it as alpha. Please remember, alpha is known to me. And then put a protractor here and please note this angle also, what is called as beta, which will help me to draw these lines parallel to this, etc. Alpha is known, beta is known, everything is known. Okay, so now the diagram is ready. What is the configuration diagram? I shall rub this now. I don't need it. Okay, this also I have still, I have made it indicated already. Now let me proceed. What is the next step? Choose a link which is having only 2 forces. Choose a link which is having only 2 forces. Which is that link? Go through that. Okay, link number 2. Anyway, we never draw the free body diagram of link number 1. Okay, and start with link number 2. Link number 2 is subjected to one torque and one force at B and another force at A. When I remove it, isolate it, if I try to draw the free body diagram of 2, it is subjected to 2 forces and 1 torque. Therefore, it is not the one which I am interested in. Now let me check link number 3. Okay, it is not having any extra force in between. And there is one force at B and one force at C. That means link 3 is a 2-force system, 2-force link. Okay, start with that. Okay, what is the first one? The first free body diagram of what? Of link 3. Okay, so this is what I am trying to draw. See, this is starting point, see, this is B. Okay, I want to draw it. So maybe a horizontal line and measure an angle alpha. So whatever it is. Okay, then I draw a line. And how much length line? Whatever BC, it is 1 1:1 scale, therefore this is what is C. So here I have one turning pair and here I have one returning pair. Okay, so here this is link 3. So here at B I have a link which is connected to link 2. Therefore I have a force from link 2 acting on link 3. At this point I have F23. Similarly at this point C, what do I have? I have a force from 4 acting on link number 3. Okay, so this member is only a two-force system and these are the names of the two forces. And how should be the two forces? This force which is passing through B, it must also pass through C. Similarly, this force which is passing through C, that also must pass through B. That means the line of action of F23 is like this, and the line of action of F43 is like this. These are the line of action. This is what is the meaning. Find line of action of each force. That's what I have done here. I hope you understand. Okay, now, so once you get the starting point, then the remaining things are very, very simple. Okay, so now, so after doing this link number 3, should I go to 2 or should I go to 4? If I go to 2, as it is F23 is not known and P2 also is not known, and therefore there won't be any starting point. Okay, you won't be able to proceed. Therefore, you have to go to link number 4. Okay, the next one is what is called as free body diagram of what? Of link number 4. Isolate link number 4 from all its neighbors. Okay, so link number 4 is nothing but DC. Okay, I start with the D. I need to draw it. I draw a horizontal line here, only construction line. This is my D. And measure what is called as beta. Measure beta. This is beta, which I know. Then starting from D, draw this line. How much? As same as C. Okay, this is C. Then I also have somewhere E. Join this, draw this point E. This is E. Okay, then at D, at point D, you have a turning pair, and at C, you have a turning pair. Remember, at E, you don't have turning pair. Don't draw a circle, small circle at point E. You don't have a turning pair. Okay, so what force do you have at D? What is the name of the force? That force is from 1 acting on link number 4. There is a force F14 at D. And what is the force at C? That force is force from link number 3 acting on link number 4. Okay, so in addition, do you know this F34? Do you have any idea about F34? Please see here, go back. F43 is known. F43 is known, and therefore F34 also is known. Not magnitude, not direction, but the line of action. The line of action of F43 and F34 are one and the same. Therefore, draw a line parallel to this. What is this? If I draw a horizontal line here, what is this angle? This angle is also alpha. So therefore, I want to represent the line of action of F34. How can I do it? Draw a horizontal line here. So measure an angle alpha and draw a line. This is the line of action of F34. Only line of action. I don't know the direction. Okay. Then apart from this F14, I don't know. I only know that it passes through point. Okay. So similarly now the third force, I have 100 Newton, a force P that is acting at E. How should I do it? Draw a horizontal line here and measure 60 degrees and draw a line. And this force is what is P, which is equal to 100 Newton. Okay, so now third force F14, I know it passes through at D, but I don't know its magnitude, I don't know its direction, therefore I normally indicate it like this. Okay, now how many forces are there? 3 forces. So what are the conditions of equilibrium for 3-force system? The 3 forces must have a common point. It is only one part of the condition. 3 forces must have a common point. This is the line of action of one force. This is the line of action of one force. Let me find out the common point of this force and this force. How? By extending this force. Okay. So this is the line of action of this. This is the intersection. Therefore, this is the common point of this and this. Okay. This must be the common point for the third force also. Join this point and the point D, and therefore this is the line of action of F14. It is no more now. That line of action of F14 is not known. No. Now I know the line of action of F14. If I extend it, it will pass through this point. Okay, draw this and it will pass through this point. Okay, so now how many forces are there? P, and this is the line of action of F34. This is the line of action of F14. Now what should I do? As I said, it is only one part of the equilibrium condition what I have utilized. What is the other condition? The three forces must have a resultant equal to 0. Or in other words, the three forces must form a closed triangle. The closed triangle. Okay, therefore, now I shall draw what is called as force polygon, and again I shall assume what is called as scale. Scale is equal to 1 centimeter, say is equal to 100 Newton. Okay, choose any point. So usually we refer it as point O. Among the three forces, which one you know? I know only P. So I start with that. I draw a horizontal line here and measure 120 degrees. 120 degrees. Draw this. How many? So 100. I need to represent only. Okay. So then I shall change the scale. 1 centimeter. I need to draw only 1 centimeter. That is too small. Therefore, I shall change it. Say probably 1 centimeter is equal to 20 Newton. I shall change the scale, and therefore this length I need to draw 5 centimeters. This is what it is. Okay. This point I shall call it again. Then at point A I shall draw one more force. One more force. What is that? One more force. I have the option of drawing either F34 or F14. It doesn't matter. Doesn't matter. I shall draw F34. F34. So at point A I shall draw a horizontal line and measure an angle alpha, and then draw a line. So why this side? Okay, I have no answer. Let me extend it this side also. The force, this is the starting point of F34. The end point of F34 may be this side or may be this side. Very soon it is going to be decided. Okay, this is F34. Now I shall remove this. Okay, it is only construction line. Okay, the next one is what is F14. F14. Okay, probably this F14 you can find out. You draw at point D and this line and without this, let this be gamma. Okay, so now drawing a horizontal line. Now why I am drawing it here? Because the end point of the third force is here. The end point of the third force is here, because I want to have resultant equal to 0, and therefore I measure what is called as gamma. Okay, so gamma. So it is slightly less than beta now. Gamma, this is beta and gamma is less, and therefore I measure what is called as gamma. Okay. Sorry, this is not gamma. This is 60 degrees. Gamma is less than beta, but beta is more than 90 degrees. Okay. So now I don't know, since I am not doing it exactly, whether gamma comes this side or gamma comes this side, that I don't know exactly. Okay. So it appears that it is compared to this force and this force, this is more vertical, and therefore probably the gamma comes somewhere here and draw this line. Okay, so slightly inclined. This is what I was telling initially. I am only indicating the procedure and you will be drawing it exactly and then you will come to know it. Okay, so now let only the forces be dark and all other construction let it be light. Okay, this is your starting point. You have drawn OA. What is that? OA, that is equal to P, which is equal to 100 Newton. From A, which is your next force, this is your next force, and this is your direction. And what is that force? This force is F34. And this is the point B, end point of the second force. At the end point of the second force, you will be drawing the third force. This is your third force. And what is that? That is F14. And go back here, F14 is in this direction. What is the direction of F34? F34 is in this direction. Okay, what is the magnitude of F34? You measure AB, so many centimeters, multiply it by 20, so many Newton, you will come to know F34. Similarly, this BO, centimeters, multiplied by 20, you will get what is called as F14. So you know F34? If you know F34, you know F43? Okay, F34 is towards right, and therefore F43 is towards left. If you know F43, you know F23. Please remember not only the magnitude, direction also. Direction and magnitude. You know F23. Okay, once you know F23, now go to the free body diagram of what is called as FBD of link number 2. Please remember, now you know F23 known. It is no more unknown now. So it is very simple. Now I want to draw the free body diagram. Choose point A and draw a horizontal line. Draw 120 degrees. This is what I have assumed it. And draw what is called as AB. Okay. So at B, what do you have? You have a turning pin at the center of the pin. The force, what is called as the force F32. F32. How is that? You draw a horizontal line, you have drawn angle alpha and represent, this is what is your F32. What is the direction? F32 is like this, exactly opposite to F23. F32 you know, okay. Then you at point A you have a force, what is that? F12, this is link number 2. F12, which is parallel to that, draw a line parallel to this. What is this? This is F12. What is the direction? F32 is like this, F12 must be like this. Now these two form what? Couple, and find out what is the perpendicular distance. Let me mark as X. F32 and F12, they will form a couple. What is the direction? Anti-clockwise. And therefore, to balance that, what you have to apply? You have to apply a torque T2. In what direction? In clockwise direction. So what is the value of T2? F32, which is known, multiplied by this X. That will give you what is T2. That is the torque that you have to apply on the input link. Okay. So this is only a routine procedure, similar, exactly similar to the one which we have done. Okay. I wish you to go through the question papers in advance. Okay. I may spend another 1 hour or another mechanism, and I want you to go through and understand. And in fact, if you have any difficulty, I want you to come back and discuss. I'll be very happy to discuss all that. But if I only go on explaining without your effort, I think I feel all that will go as best. So therefore, probably with one more class, I shall wind it up and then move on to another topic, and unless I get some feedback to continue. Okay, all the best. Take care.